Okay, I hope I'm audible to all students who are attending this lecture of statistical methods for economics. We continue with our practice problems on probability in this lecture. So, practice problems based on concepts of probability. Students can recall that in the previous practice lecture, we were doing a couple of problems based on the cards and how to find probability based on deck of cards, etc. Okay, so now in this particular lecture, let's practice a few more problems. So the first question for practice, okay, let's look at part A to this question. Among the digits 1, 2, 3, 4, 5, at first, one is chosen, and then a second selection is made, and then a second selection is made among the remaining 4 digits. Okay, assuming that all the possible outcomes have equal probabilities, assuming that all the possible outcomes have equal probabilities, the question asks us find the probability that an odd digit, find the probability that an odd digit will be selected the first time. What is the probability that an odd digit will be selected the first time? The odd digit will be selected the second time, and probability that the odd digit will be selected both the times. So students, let's quickly solve this problem. Okay, we are given that there are 5 digits, 1, 2, 3, 4, 5. We select one digit and then we select another digit among the remaining 4. That means there is no replacement happening. What are the total number of outcomes? So I can write possible outcomes, total possible outcomes. So possible outcomes in total are, what are the possible outcomes? If I can select 1, second digit can be 2, or with 1 the second digit can be 3, or with 1 the second digit can be 4, or with 1 the second digit can be 5. Similarly, with 2 the second digit can be 1, with 2 the second digit can be 3, with 2 the second digit can be 4, and with 2 the second digit can be 5. Similarly, with 3 the second digit can be 1, with 3 the second digit can be 2, with 3 the second digit can be 4, with 3 the second digit can be 5. Similarly, with 4 the second digit can be 1, with 4 the second digit can be 2, with 4 the second digit can be 3, with 4 the second digit can be 5. And similarly, with 5 the second digit can be 1, with 5 the second digit can be 2, with 5 the second digit can be 3, or with 5 the second digit can be 4. Let's count how many outcomes are there in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. That means my total number of outcomes are 20. Now let's find the favorable outcome. So we want an odd digit to be there the first time. So from the sample space, at the bottom, what you can see is the sample space. Total possible outcomes is my sample space. Okay. What are my favorable outcomes? I want, so I'm using red color now to solve the first one. I want the odd digit to be there the first time. So this is a possibility 1. 2, 3, 4, then 5, because 3 is an odd digit, 6, 7, 8, and then 9, 10, 11, and 12. That means if I look at the first case, guys, where we want the number of outcomes to be, the first digit to be odd, there are 12 possible outcomes. Students can see. There are 12 outcomes. So my required, so favorable outcomes is 12. Because we want the first digit to be odd. That means out of all the digits given, there are 3 odd digits, 1, 3, and 5. So if I count the number of outcomes, I get 12 outcomes. So my required probability is, I'm writing the answer here. This is my answer. Required probability is, these are my answers I'm writing for required probability. So in the first case, my required probability is 12 upon total number of outcomes, 20. This is my answer. Then I want, let me use blue color now for the second case. I want the odd digit to be the second digit now. Now, what are the possibilities for odd digit to be the second digit? This is one possibility. Then this. Then this. This one. Then we have this one. Then we have this one. This one. This one. This one. This one. This one. All the blue circled ones represent the cases where the second digit is odd. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. I hope we have not missed out on any case. So let's check it again. Students can also check along with me. We want the second digit to be odd. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12, guys. Again, in the second case also, I can say that there are 12 favorable outcomes. The number of favorable outcomes are 12. So what is my required probability? 12 by 20. And now I use the pink color. We want the odd digits to be there both the times. Now, how many odd digits are there both the times? Let's look at the favorable outcomes. This is 1 in pink, 1. Then we have 2. Then we have 3, 4, and 5, and 6. If you look at the pink circles, there are 6 of them. That means my answer for the last part is, first of all, I can write that my favorable outcomes for the last part are 6, and my required probability is 6 by 10. So these are my answers for question number 1, part A. Okay, so I hope that all students have understood this. Let's now look at part B to this problem. So question 1, part B. Okay, so I can write that from 25 tickets, this is my question, from 25 tickets marked with the first 25 numerals. First 25 numerals means numbers 1 to 25. One is drawn at random. One is drawn at random. 25 numeral means numbers 1 to 25. Let me clarify this. So one is drawn at random. The question asks us find the probability that, find the probability that part 1, it is a multiple of 5 or 7. It is a multiple of 5 or 7. Part B asks us it is a multiple of, find the probability that it's a multiple of 3 or 7. So let's quickly solve. Again, this is an easy problem. There are 25 tickets numbered 1 to 25. So what are my total number of outcomes? In both the parts 1 and 2, my total number of outcomes are 25 because I have 25 tickets and they are marked 1 to 25. Now, what are the favorable outcomes for part 1? So what are the multiples of 5? The multiples of 5 are 5, 10, 15, 20, 25. Will I take 30? No, because the tickets are only marked 1 to 25. So my multiples of 5 are these. What are my multiples of 7? Multiples of 7 are 7, 14, 7, 3, 21, 28. But will 28 come? No, because again the numbers are marked 1 to 25. So what are my favorable outcomes? For part A, my favorable outcomes are, here I have how many outcomes? 1, 2, 3, 4, 5. Here I have 3 outcomes. So favorable outcomes are 5 plus 3, which is 8. Because the ticket should either be a multiple of 5 or 7. So what is my required probability? The required probability is favorable outcomes 8 upon total number of outcomes 25. This is my answer for part 1. And now it should be a multiple of 3 or 7. So now everything remains the same. Okay. It's just that instead of using 5, I have to use 7. Instead of using 5, I have to use 3. Let me correct myself. Multiples of 3 are what, guys? 3. 3 2s are 6. 3 3s are 9. 3 4s are 12. 3 5s are 15. 3 6s are 18. 3 7s are 21. 3 8s are 24. Will I take 3 9s are 27? No, because the tickets are marked till 25. So how many outcomes I have? 1, 2, 3, 4, 5, 6, 7, 8. And here I have 3. So my favorable outcomes are 8 plus 3. My favorable outcomes, I'm doing part 2 now. Okay. This is part 2. And my favorable outcomes are 8 here, 3 here. So 8 plus 3 is 11. Required probability is favorable outcomes divided by total number of outcomes, which are 25. Okay. So I think there's a small mistake I have made. I think I've counted 21 twice because 21 is common in both. So let me correct this. Let me correct this. Multiples of 3 and 7. So 21, if I'm counting here, there is no need to count 21 here. Because a ticket with the same number can't come more than once. Okay. So that means let's avoid 21 here. Because I'm already counting 21 here as a multiple of 7. So that means 21 should not be counted twice. It should only be counted once. So how many outcomes are there here? 1, 2, 3, 4, 5, 6. So 6 plus 3. And I forgot 24. Let me write 24. So let me erase this. And let me write 24. Let me write 24. So remember, I am not counting 21 because 21 I have already counted in multiples of 7. So I am ignoring that in multiples of 3. because we cannot count 21 more than once. So how many outcomes are there now? 7 outcomes. 1, 2, 3, 4, 5, 6, 7. 7 and 3 make it 10. So make a correction here, students. This is 7 plus 3, which is 10. Seven outcomes here, 3 outcomes here. My required probability is 10 by 25. This is my answer for part 2. So I'm repeating it again. In part 2, we were asked to find the probability that the tickets are a multiple of 3 or 7. The multiples of 3 are 3, 6, 9, 12, 15, 18, 24. Why have I not counted 21? So I can write 21 also. I can write 21 also, but I'm not counting it because 21 is already counted here as a multiple of 7. I can't count the ticket more than once. I'm repeating it again. Multiples of 7 are 7, 14, 21. So 7 outcomes there, 3 outcomes there, total outcomes 10, required probability is 10 by 25. Okay. So hoping students have understood this. Then let's quickly move forward to the next question. Okay. So we are done with question number 1 now. Let's look at question number 2. So a committee of 4 people is to be appointed from 3 officers of the production department, 3 officers of the production department, 4 officers of the purchase department, 4 officers of the purchase department, 2 officers of the sales department, 2 officers of the sales department, and 1 chartered accountant. 1 chartered accountant. Find the probability of forming the committee in the following manner. Find the probability of forming the committee in the following manner. Part 1 asks us, there must be 1 from each category. In the committee, there should be 1 from each category. Part 2 asks us, it should have at least, or let's do one thing. Let's solve the first part. Let's solve the first part. Then we'll talk about the second part. So guys, a committee of 4 people needs to be formed. Okay. We have the following departments. If I just draw a flow chart, we have the production department. We have the production department. We have the purchase department. Let me write DEPTT as short form, purchase department. Then we have sales department. And then we have chartered accountant, CA. How many people are there in the production department? There are 3 officers in production department, 4 officers in purchase department, 2 officers in sales department, and 1 officer in chartered accountant. And we need to form a committee of 4 people. Okay. So what are the total number of ways? First of all, what is the total strength of the department? Okay, 3 are in the production, 4 are in the purchase. So 3 plus 4 plus 2 plus 1 CA. So the total number of people in the department are how many? 3 plus 4 plus 2 plus 1 is 10. That means there are 10 people working in the department. I need to select 4 people. In how many ways can I select 4 people from 10 people? Remember combinations. Total number of outcomes is what? Total number of outcomes is I have to select 4 people from 10 people. So 10C4 denotes my total number of outcomes. And now you can calculate this. It's 10 factorial upon 4 factorial. 10 minus 4, 6 factorial. Students by now should know how to work out the factorials. The answer is 210. Now this is my total number of outcomes. Favorable outcomes is what? I need 1 from each department. So if I erase the initial part, I'm erasing the question now. We don't need the question. Students can see the flow chart. I've drawn on the screen, so that should be sufficient. I'm erasing the question now. Now let's see what are the favorable number of outcomes. So I can write favorable number of outcomes are how much? What are the favorable number of outcomes? I want 1 from each category. That means from 3 people in the production department, I need 1. And means multiply. From 4 people in the purchase department, I need 1. And from 2 people in the sales department, I need 1. And I just need 1 CA, and in the department, there is only 1 CA. So that's 1 only. So 1 person should be selected from 3 in the production department. 1 person should be selected from 4 in the purchase department. 1 person should be selected from 2 in the sales department, and you only need 1 CA, and there is 1 CA. So if you calculate this now, I mean, you can work this out yourself now. Students by now should know how to work out the combinations. You should have watched my lectures on probability theory by now before attending this practice lecture. Okay. So when you solve this, you get the answer as 24. So my required probability for part 1 is favorable outcomes 24 upon total number of outcomes 210. This is my answer for part 1. Then let's see what part 2 is asking us. So I erase this part off now. Okay. And I can write part. I'm erasing this part also now because students should have done this by now. Let's look at what part 2 is asking us. So part 2 is asking us the following. Find the probability of forming the committee. Find the probability of forming the committee if there should be at least 1 from the purchase department. If there should be at least 1 from the purchase department. So now all students know from my theoretical lectures on probability that what is the probability of at least 1? Probability of at least 1 from the purchase department is 1 minus probability of no one from purchase department. No one from purchase department. Okay, so I hope that students have understood how we have built this equation. First of all, probability of at least 1 from the purchase department, I need at least 1. So 1 minus probability of none from the purchase department. Now how do I find none? Now probability that there is no one from the purchase department will be Favorable outcomes upon total number of outcomes. Total number of outcomes we all know 210. Okay, that's 210. What are the favorable number of outcomes? Now, if I remove the purchase department completely, how many people are there in the purchase department? 4. Remove 4 people from the department. How many are left? From 10 people, if I remove 4 people of the purchase department, 6 people are left. Out of these 6 people, I need to select 4 people. Because in the beginning of the question, it was given that the committee needs to be formed from 4 people or 4 people. So probability that I will not come across anyone from the purchase department is, I need to select 4 people from 6 people. These 6 people are not from the purchase department because I have removed all people of the purchase department. From 10 people, I subtract 4, I get 6. Now, when you use your calculators and when you do the algebra part, do the solving part yourself, basically, you get the answer for this. 64 by 210 is how much? It's 15 by 210. And 15 by 210 simplify, it's 1 by 40. So probability that no one is from the purchase department is 1 by 40. So I need to find what? Probability at least one is from the purchase department is 1 minus 1 by 40. So this answer is nothing but 1 by 40. We have found it out. Probability that at least one is from the purchase department is 1 minus probability that no one is from the purchase department. And probability that no one is from the purchase department is 1 by 40. So 1 minus 1 by 14 is 13 by 14, which is the final answer for this question. 13 by 14 is the answer for this question. So I hope students are again clear with this. And then let's look at the last part to this particular problem. So I'm erasing third part completely. Erasing this part off. Let us look at the third part. So find the probability of forming the committee. Find the probability of forming the committee if the chartered accountant must be in the committee. If the chartered accountant must be in the committee. Now we want the chartered accountant to be there in the committee. So again, my total number of outcomes is 210. That's not changing. Total number of outcomes is 10C4 and 10C4 is found out at the bottom of the screen as 210. What is the favorable number of outcomes? Now one chartered accountant should be there. So one chartered accountant is there, and now I need to select only 3 people because the committee should consist of 4 people. I have already selected the CA. So now 3 people I need to select from how many people? Now, since I've already selected the CA, the department has how many people now? Let's calculate that. The department in total had 3 plus 4 plus 2 plus 1, which is 10 people, right? Now I have already selected the CA because the CA must be there in the committee. So how many people are now left to be chosen from? 3 plus 4 plus 2. That means 9. From 9 people, I need to select 3 people and I have a CA. So my favorable number of outcomes is 9C3 times 1. I'm repeating again. From 9 people, why do I need to select from 9 people? Because this one CA is already selected. So the options I have is 9 people. From these 9 people, I need to select 3 people and 1 CA makes it 4 people. Use your calculators. Verify that 9C3 is 84. So my required probability is favorable outcomes, which are 84, upon total number of outcomes, which are 210. Verify that 84 by 210 is 2 by 5. This is my final answer for part. Okay, so students, this is where I stop in this particular lecture. Again, the objective was to do a couple of practice problems on probability. In the next lecture, I'm going to continue. In the next practice lecture, we continue with more numericals on probability. We continue with more numericals on probability. So I stop in this lecture. I hope all students have enjoyed this lecture. Any doubt? You can get in touch with me on mail at divineschoolofelconomics@gmail.com. This is where I stop in this lecture.